Hello world, Liu here, and today let's run through and explain every single keyword in Python. So if you're new here, I'm a software engineer from Singapore, and I create content that aims to bring your Python skills to the next level. Now back to the video. So here, the def keyword allows us to write our own functions. Functions are small code blocks that can be reused. And for example, we define hello, and we simply print hello twice. So if we call our function, which means to use our function, we'll print hello twice. And here we have it. Next, return signifies the output of our function. So let's say I have a define at 10 and I take in a number n. So I return n plus 10. So here, whatever comes after the return statement is the output of our function. So here, for example, x equals to add 10, let's say 3. So I'm supposed to get 13. So if I print x, I'm going to get 13. So here, another thing to note is that nothing happens after the return statement. So here I can print hello, but this line is useless because it happens after the return statement. So if I run this once again, hello does not print because it happens after the return statement. Next, we have the u keyword, which also signifies the output of our function. However, the main difference against return is that stuff can still run after the u statement. So here, let's say define test. So return 1, return 2. And here, test 2, u1 and u2. So here, if we print test, notice that we only return 1. So once again, nothing happens after the return statement. And as such, we do not ever reach return 2. However, if we try to call test2, we are going to get this generator object. So this is what the u keyword causes to happen. So in order to properly call this, we have to put this in a for loop. So for n in test2, I'm going to print n. So this is the proper way to call a generator object. So once again, if I run this, I'm going to get 1, 2. So here, notice that we u1. So here, notice that we u1 and then we u2. So here, I can add more u's if I want, u3, u5, and u100. So here, once again, if I run this, I'm going to get 1, 2, 3, 5, and 100. And all of this is possible because of the u keyword. Next, the lambda keyword allows us to write anonymous lambda functions. So here is a lambda function. So lambda x plus 10. So here, what this means is essentially, we input 10 and we get back x plus 10. So this is the exact same as at 10. So x return x plus 10. So this is the exact same as this, except that this is anonymous, which means that it is optional to give it a name. So to give it a name, I can simply do this at 10, and it will be the exact same as this code over here. However, I can choose not to give it a name, and that's what it means by being anonymous. So here, lambda functions are pretty useful in higher order functions, which are functions that can take in other functions. For example, define apply. So I put a list and a function. So for n in list, I'm going to print n and function n, and let's say we have a list is equals to 1, 2, 3, and we apply list and we pass in our add 10. So here we are applying add 10 to every single element in our list. So if we run this, we are going to get 11, 12, and 13. So here, our anonymous function can actually be put directly here. So we don't have to even define the add 10 over here. And if we run this, we'll get the same result. So this lambda function, which is anonymous, is applied to every element in our list. Next, the none keyword signifies a none type. And if we don't return anything in our function will return none by default. So let's say define hello, and I print hello, but I do not return anything. So let's say if I do this, x is equals to hello, and if I print x, I'm going to get none. So here, this hello is from our print statement here, but this none is from our print statement here. So x is equals to hello, but hello returns none, which means x is none. Next, the with keyword allows us to use context managers. So let's say we want to read a certain file. So let's say we have a.text and we have apple orange pear. So with open a.text sf and text is equals to f.read, and let's print text. So let's run this and we are going to get apple orange pear. So here with something as something else. So here this thing is a context manager. So here the purpose of this context manager is to ensure that something runs at the start and something runs at the end. And in the case of file reading, our file will always be closed if we use a with keyword. For example, if we comment this out and we did something like this, so file is equals to open a.text, and we do some text is equals to file.read or something like that. So if we do this, there's a chance that this will not close, which is not best practice and can lead to further memory problems down the road. So here using the with keyword allows us to avoid this problem. Next, the as keyword allows us to use aliases. So in our previous example, we have with open a.text sf. So here sf means that we are renaming this thingy as f. So we print f, and let's see. So here we have this io.text io wrapper thingy, which is what f is. So here we can choose to rename it file, and here if we put file, then it will be named file instead. So another way we can use the as keyword is in imports. So let's say I want to import numpy, so import numpy, and here I can add as np. So here with this alias, I can simply use np instead of having to type out numpy. So let's say np.array, and I pass in an empty list. So here, notice that I do not need to type out numpy in full. Next, the import keyword allows us to import other Python libraries. For example, if I need to use numpy for some number stuff, I can import numpy as np. I can import other stuff like request and so on. So if I print request, I'm going to get a module, and I can use the various functions in this module. Next, the from keyword allows us to import a specific part of a module. So let's say I only need array from numpy. So there are two ways I can do this. Import numpy as np, and then I create an array. So let's say print np.array, and I pass in this thing. Or I can do this from numpy import array, and I can print array directly without having to use np. So let's comment this out. And so if I run this, I'm going to get my numpy array. And next, the del keyword allows us to delete stuff. So let's say we have a is equals to 4, b is equals to 5, and c is equals to 6. So if we print a, b, and c, we are going to get 4, 5, and 6. However, if we do this, delete c, we will get an error because c is not defined. So here, if we delete c, c will be deleted. So this works also for dictionaries. So let's say I have d is equals to 1 is to 2, to 3 is to 4, and 5 is to 6. And let's print c, and let's say I delete d3. So here, if I run this, I'm only going to get 1, 2, and 5, 6. Because I deleted d3, which means that this key value pair will be gone. So here, if I delete d5, 2, I'm only going to get 1, 2. And here we have it. And next, we have the true and false keywords. So these are the only two values of the Boolean type, and they are used in conditional statements. So for example, if true, I print 1, 2, 3, and if I run this, I'm simply going to print 1, 2, 3. However, if I replace this with false, I'm not going to print anything. However, we don't usually use it like that. We use it in a conditional statement. So for example, x is less than 5. So let's define x because we haven't done that. So x is equals to, let's say, 3. So if we do this, we'll have 1, 2, 3. So over here, x less than 5, this expression here will evaluate to either true or false. And in this case, because x is 3, this will evaluate to a true. So let's say if I put x is equals to 30, this will evaluate to a false, and we will get nothing. And afterwards, we have and, or, and not. So these keywords are logical operators, and they are used in conditional statements with multiple conditions. So let's say I have a score is 90, and I have a conduct is equals to okay. So let's say to get a scholarship, our score needs to be more than equals to 90 and conduct needs to be equals to grade. So let's write some code to do this. So if score is more than equals to 90 and I use the N keyword, and next conduct is equals to grade. So only if these two conditions are fulfilled, I print scholarship. And let's say else, I print no scholarship. So if I run this, I'm going to get no scholarship because conduct is okay and not grade. So here in this statement, because of the N keyword, both this condition and this condition must be true for the entire condition to be true. So if only I change it to grade, scholarship will print. So here, if I replace this with all, either one of these conditions need to be true for the entire statement to be true. So let's say conduct is bad, and if I print this, I'm still gonna get scholarship because of the or statement. Here I change conduct to bad, and this is false, but because score is 90 or more, this entire expression is true, and so scholarship will print. And finally, let's say x is true, and if I print not x, I'm gonna get false. So here, adding a not in front of a boolean will simply flip it. So true becomes false and false becomes true. Next, we have the if, else if, and else keywords. So we use them to write conditional statements. So there must be at least one if statement. So let's say x. So let's say score is more than equals to 90. And let's define score here. Let's say 85. So if score is more than 90, we print, let's say A. So if we run this, we'll get nothing because score is not more than 90. So next, we can write else if score is more than 80, we print B, and let's say else if score is more than 70, we print C. So if I run this, I'm gonna get B because score is 85. So over here, we must have one if statement, but we can have as many else if statements as we want. And finally, we have our final else statement. So here, the else statement will run if all of these are false. So here, let's say I print fail, and let's say I change this to 8. So if I run this, I'm going to get fail. So once again, we can only have one of this and one of this in a specific if block, but we can have multiple else if blocks. Next, the type keyword can be used to find the type of a value. So let's say x is equals to 4, y is equals to apple, and z is equals to dictionary 1, 2, 3, 4. So here, I'm going to print x and also the type of x. So if I run this, I'm going to print x first, which is 4. And because I print the type of x, I'm going to get class int. So this is the type of x. However, if I change this to y, then we are going to get a different type. So apple and class stir, which stands for string. So here, if I change to z, I'm going to get a different type once again. So here we have our dictionary and our type will be class dic. Next, the class keyword can be used to write classes, which is used to initialize objects. Here, let's say I define a class, so class dog, and I pass. So this is a dog class, and next we have a Rocky, which is a dog object. So if I print Rocky here, I'm going to get a dog object. So this is a dog object, and this is a dog class. So here in Python's object-oriented programming, there are many more useful functions that we can learn, such as init. So define init, so self, name, age. So let's say our dog has a name and an age. So self name is equals to name, and self age is equals to age. So here I can print Rocky, Rocky.name, and Rocky.age. And so if I run this again, I'm going to get, oops, let's enter a name, and let's enter a age. So once again, if I run this, I'm going to get this dog object, which is the result of printing Rocky, the Rocky's name, and Rocky's age. Next, the for keyword is used to write for loops, which can be used to repeat actions a finite number of times. So let's say I want to print apple 5 times. So for I in range 5, and I print apple. And so if I run this, I'm going to have 5 apples. So let's say if I change this to 50, I'm going to get 50 apples. So that's a lot of apples. Next, we have the while keyword. which we can use to write while loops to repeat actions infinitely until a certain condition is met. So for example, x is equals to 0, and while x is less than 5, let's print x, and x plus equals to 1. So if we run this, we'll get 0, 1, 2, 3, 4. So what's happening here is that while condition, we do whatever is happening here. So here, this will run forever and ever until this condition becomes false. And next, the pass keyword allows us to do nothing. And usually this is used as a placeholder in our functions. So let's say I define hello, but I have no idea what to write yet, so I can simply write a pass here. And this will allow my code to run. So let's say x is equals to 1, and if I run this, the code will run. However, if I do not put the pass, then there will be a syntax error. So here I can put a pass as my placeholder for now. And next, for the break keyword, we write this inside for and while loops. So when the break keyword executes, it stops whatever loop is in immediately. So let's say for I in range, let's say 1 to 5, I'm going to print I first, and if we run this, we are going to get 1 to 5. However, if I do this, if I is equals to 3, I am going to break. So if I run this again, I'm going to stop at 3, because once I is 3, I break, and this entire for loop will stop. And next, we have the continue keyword. So similarly, we write this inside our for and while loop. However, this just stops the current iteration immediately and moves on to the next iteration. So let's say for I in range 1 to 5 again. If I print I, I'm just going to get 1 to 5. However, if I modulo 2 is equals to 1, which means that if I is an odd number, I will continue. However, over here, I print I. So if I run this again, I'm only going to print the even numbers. Because if it is odd, I continue, which means I skip to the next iteration immediately. Next, we have the try and except keywords. So here, we use the try keyword to attempt code that might cause errors, and we use the except keyword to define how to handle that error. So let's say I have x is equals to 1 plus apple. So here we are trying to add an integer with a string, which will definitely cause an error. So instead of just writing it normally, let's put this inside a try block. So try, and afterwards we have except. So print error with a few exclamation marks. So here, if I run this, I'm going to get error. So what's happening here is that because this is in a try block, whatever error that happens here will be caught by our except block. And if that happens, we will print error. However, let's say nothing happens in the try block. So x is equals to 1 plus 1. So this is perfectly fine code. And if we do this, the except block will not run. And next, we have the finally keyword. So here, finally is usually used with try and except. So try, x is equals to 1 plus apple, except print error happens, exclamation mark. And finally, I'm going to print this runs no matter what. So here, if I run this, I'm going to get error happens and this runs no matter what. And this is because I attempt to add an integer with a string. So here, this will cause an error which causes the except to happen. Also, our finally will happen whether or not there's an error. So let's say I replace this with a OK code. So x is equals to 1 plus 1. And if I run this, I'm going to get this runs no matter what. So once again, finally runs no matter if there's an error or not in try. Next, we have the assert keyword. So usually we use the assert keyword as a sanity check. So let's say I have x is equals to 1 plus 1. So next we are going to do our sanity check. So assert that type of x is equals to an integer. So let's just print hi. So here, if we run our code, nothing will happen because x is in fact an integer. So at this point, we are doing some sort of sanity check just to ensure that x should be an integer. And if x is something else other than an integer, something is very wrong. However, let's say x is equals to apple. So let's say there's some bug that causes x to become apple. And if we run this, we'll get an assertion error. So here, x is supposed to be an integer, but it is a string. And that is why it is being caught by our assert statement. Next, we have the raise keyword. which we can use to forcefully cause an exception to happen. So let's say x is supposed to be an integer again, and if type of x is not equals to integer, we can forcefully raise an exception. So raise, let's say exception, why is x not an integer? So if I run this, nothing will happen because right now x is an integer. However, if I replace x with, let's say, a string or something else, and if I run this, I'm gonna get an exception. And notice that I can pass in my exception message here. So exception, why is x not an integer? So here the raise keyword is also quite useful if you want to debug stuff. And next we have our match and case keywords. So this can be an alternative to our if-else blocks. So let's say I have a fruit is equals to apple, and I'm going to use a match case. So match fruit colon indent case, let's say apple, and I'm going to print apple pie, I guess. Then next is case is orange. So here I'm going to print orange juice or something like that. And case pear, and I'm going to print pear cake if there's such a thing. So here if I run this, I'm going to get apple pie. And this is because fruit is equals to apple. So what's happening here is that because fruit is apple, we will search for the case where fruit is equals to apple. So here if we replace this with an orange, we will get orange juice instead. So let's run this and double check. And here we do get orange juice instead. And next we have the in keyword. So we use this to check if something contains another thing. So let's say we have a list is equals to apple, orange, pear. And let's say we want to check if apple is inside list. So we print, let's say apple in list. So if we do this, we will get true because apple is in fact inside our list. However, if we put something else like pineapple, which is not inside our list, we will get a false instead. And next we have our is keyword. So here the is keyword is used to check if two variables refer to the same object. So let's say x is equals to list 1, 2, 3, and y is equals to x. So here they are actually referring to the same object over here. So if I print x is y, this will be true because they are in fact referring to the same object. However, if I rewrite this, so let's comment this out. So instead, if I create another new list, so here x and y are both the list 1, 2, 3. However, they are not the same object as I'm actually creating another object with the exact same elements, but they are still not the same object. So if I run this again, it will become false. Next, we have async and await, which is used to create asynchronous Python functions, also known as coroutines. So here, let's say async define my CR, which is my coroutine. And here I'm going to print hi. And next I'm going to await, which is in a way to wait for, async io dot sleep 1. So this will just make our function wait. So here, let's say coroutine ended. So here we have this squiggly yellow line, so we need to import async io. So here, if we attempt to call this like we do with other normal functions, we will probably get an error because this is not the way we are supposed to do it. So here, when a coroutine is called, it returns a coroutine object, and this coroutine object should be passed to the event loop. So let's quickly run through how we can actually use this. So let's say I've entered async define min, and here we have await async io gather my CR, and my CR. So here we run this 3 times concurrently. So here, let's say async io dot run min. So if we run this, we will get 3 high and 3 coroutine ended. So here, notice that this function calls do not wait for each other to complete. So that is the whole purpose of this async io library. And next we have the global keyword. So here the global keyword is used to define a global variable. So let's say I have x is equal to 5 and define test, and here I set x is equals to 10. And let's say if I print x. So here nothing will happen because I haven't called my function. But if I call my function, nothing will still happen. It's still going to be 5. And this is because in this function, x is a local variable. However, we can change it using the global keyword. So global x, which means that any x that happens inside this function will refer to the global x, which refers to this x. So if I global x here, and if I set x is equal to 10, it means that this x will be overridden with 10. So if I run this again, it will become 10. And finally, we have the non-local keyword. So this is like the global keyword, but it's used on variables inside nested functions instead. So let's say I have defined test. So x is equals to 5, and I have defined test2, a nested function, and x is equals to 100. So I'm going to print x, and I'm going to call test2. So outside here, I'm going to call test, and we should print 5. And here we have it, 5. So over here, even though we call test2 and we set x is equal to 100, x is actually not set to 100 because this is inside the local scope of this function. However, if we do this non-local x, this non-local x will actually refer to this x. So if you run this again, we'll get 100. So once again, thanks for watching, and hopefully this was clear and easy to understand. See you in the next one.